My name is Singeza Ibrahim. I'm a Ugandan researcher, and I was able to find out that numbers correspond to each other throughout the counting system. This is the first mathematical proof produced by a Ugandan. So ladies and gentlemen, let us witness the proof of the numeric correspondences. The proof of numeric correspondences. So the question is, what is numeric correspondence? What is numeric correspondences? Numeric correspondences is where numbers correspond to each other throughout the counting system. So we are going to look at terminologies that are used in numeric correspondences. So terms used in numeric correspondences. Terms used in numeric correspondences. The first term is going to be the numeric locator. Numeric locator. So what is a numeric locator? This is the arrangement. This is the arrangement of natural numbers. Of natural numbers in the first quadrant. And those numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. So another term is going to be quadrat. So what is a quadrat? A quadrat is a habitat of various nine numbers in the counting system. It is the habitat of various nine numbers in the counting system. These quadrats range from the first quadrant, second quadrant, third quadrant, up to infinity, as we will see in the future. So, quadrats are listed in two forms. Quadrats are listed in two forms. One, the horizontal alignment. The horizontal alignment. So how do we write the horizontal alignment? This is the horizontal alignment. So this is the horizontal alignment. Another format how quadrants are listed is called the vertical alignment. The vertical alignment. So the following is going to be the vertical alignment, and it is written like this. Yeah, but throughout the process, I prefer using the horizontal alignment. But everything which is done to the horizontal alignment, it is done to the vertical alignment. But throughout, we are going to use the horizontal alignment. So we go to our third term. Our third term, which is called the quadrant number. So what is the quadrant number? A quadrant number is the position of a quadrant in the counting system. It's the position of the quadrant in the counting system. Quadrant number is the position of the quadrant in the counting system. Counting system. So, for example, Iggy, when we write 1, 2, 3, 4, 5, 6, 7, 8, 9. This is termed as the first quadrant. And it is the same quadrant which I said is used as the numeric locator, is used as the basis of all numbers in the counting system. Another quadrant, it begins from where you stopped, 10, 11, 12, 13, 14, 15, 16, 17, then 18. So this is the second quadrant. Then another quadrant, it begins where you stopped, 19, 20, 21, 22, 23, 24, 25, 26, 27. This is the third quadrant. So another quadrant begins from 28, 29, 30, 31, 32, 33, 34, 35, 36. This is the fourth quadrant. Fourth quadrant. So these quadrants go on up to infinity. You can write them fourth, fifth, sixth, up to infinity. Fourth term. Our fourth term is called beginning number. Beginning number in a quadrant. Any number that begins a quadrat, it's called a beginning number. For example, Iggy. In this first quadrant, 1 is the beginning number. So let us look at our fifth term, which is called last number. In a quadrant, Iggy, I'm using the second quadrant, which begins from 10, 11, 12, 13, 14, 15, 16, 17, 18. So, last number here is 18, and the beginning number is 10. Last number here is 9, and it goes on throughout all quadrants, as we have mentioned previously. Sixth term, which is called numeric sum. So, numeric sum, what is numeric sum? When a single digit is added repeatedly onto another single digit, to get a final digit. This is known as numeric sum. When a single digit is added repeatedly onto another single digit to get a final digit, it's known as numeric sum. So let me show you with examples. But before I show you an example of numeric sum, just know that every number in the counting system must add up to one of the numbers in the first quadrant, which is called the numeric sum, which is called the numeric locator. So this is the first quadrant. So every number in the counting system in all quadrants must add up to one of the numbers in the numeric locator of the first quadrant. So let us look first on the numeric sum. So how do we find the numeric sum? Iggy. The numeric sum of 10 is 1 plus 0, which equals to 1. So the numeric sum of 10 is 1. The numeric sum of 19 is 1 plus 9, which equals to 10. Then 1 plus 0. Why are we adding again 1 plus 0? Because we will have to add a single digit. So this is 1 plus 0, which gives us to 1. So this one already shows that, as we will see in the future, that 19 corresponds to 10, since they have the same numeric sum. So let us try somehow a different number. The numeric sum of 34 is 3 plus 4, which equals to 7. So let us find the numeric sum of a number which is somehow bigger. So a number which is somehow bigger, we find the numeric sum of 1075, which is 1 plus 0 plus 7 plus 5. We can add together. 1 plus 0 is 1. 1 plus 7, then plus 5. This is 13, not so? Then find the numeric sum of 13, which is 1 plus 3, which equals to 4. So the numeric sum of this number, 1075, is 4. NB, when every number in the counting system beginning from 1 is added onto 9, its numeric sum is always equivalent. Let us see it in examples. E.g., 1 plus 9 equals to 10. So the numeric sum of 10 is 1 plus 0, which equals to 1. 1 is the same as this, which shows that when every number in the counting system is added onto 9 and you find its numeric sum, it is always equivalent to the number it's added on. Let us see another example. 34 plus 9. So this, everybody knows that this is 43. When you find the numeric sum of, let us find the numeric sum of 34 first. 34, the numeric sum of 34 is 3 plus 4, which equals to 7. And the numeric sum of 43 is 4 plus 3, which equals to 7. So let's find a numeric sum of somehow a big number. You know, let's add a certain number which is somehow big to 9 and we see if it works in all numbers. Let's add 1009 plus 9. This equals to 1018. Find the numeric sum of this. The numeric sum of this number is 1 plus 0 plus 0 plus 9, which equals to 10. 1 plus 0, which equals to 1. Then let us find the numeric sum of this number we added. Let us find the numeric sum of this number, which was got after adding 9. So 1 plus 0 plus 1 plus 8. So 1 plus 1 equals to 2 plus 8, which equals to 10. So 1 plus 0 equals to 1. Have you seen? This works in every number in the counting system. Any number you choose and you add it onto 9, its numeric sum is equivalent to the original number added onto 9. So another thing to note is that every last number in the quadrant is always divisible by 3 and 9. Let us see. This is the first quadrant. First quadrant. Then the second quadrant begins from 10, 11, 12, 13, 14, 15, 16, 17, 18. So that is the second quadrant. So let's stop on the third quadrant, which is 19, 20, 21, 22, 23, 24, 25, 26, 27. So I told you earlier, another thing to note is that every last number in the quadrant is divisible by 9 and 3. Let us see. The last number here is 9, it is divisible by 9 and 3. And the last number here, it is divisible by 9 and 3. And the last number here, it's divisible by 3. And all these numbers on this side, up to infinity, they are all divisible by number 3. That one you can work it out at your home, because this is the third quadrant. As I told you that quadrants continue from the first quadrant up to infinity. You can write even up to 1,000 quadrant, but it's so tiresome. You can write books and books. So I'm going to show you what is next. I'm going to show you how to find numeric correspondences and list quadrants in a very simple way. You can list even the 1 billionth quadrant if you like. So our next thing here is called finding numeric correspondences. Finding numeric correspondences. So finding numeric correspondences is what we want to know how it works out. So what we are going to begin with is the formulas used in numeric correspondences. Let me use that short term, NC. Formulas used in numeric correspondences. The first formula is called the quadrant number. As we saw it in terms used in quadrant number. Quadrant number equals to last number in a quadrant divided by 9. So the reason why we divide by 9 is that every quadrant has 9 numbers. And another formula is we are going to look at beginning number. The formula of beginning number equals to quadrant number times 9 minus 8. Why do we subtract by 8? It's the question, because we have known there is 9 numbers in the quadrant. So look here, let us take that this is our quadrant. 1, 2, 3, 4, 5, 6, 7, 8, 9. We know our last number, it is 9. So when you count to get the beginning number, which is 1, when you know the last number in the quadrant, it is 9 minus 8. Why 8? Because you are finding our beginning number. So it is this, when you remove this, because we already know our last number. So the rest of the digits, 1, 2, 3, 4, 5, 6, 7, 8, they make it to 8. 1, 2, 3, 4, 5, 6, 7, 8. That's why we subtract to 8 to get our beginning number in this quadrant, which is 1. So another formula used, it is called the last. But before I proceed with another formula called the last number, you know this beginning number, you can find beginning number again by saying last number minus 8. Last number minus 8. So we are about to find out why we say that beginning number equals to quadrant number times 9 brackets 8. So last number here equals, last number equals to quadrant number times 9, or beginning number, last number equals to beginning number plus 8. So when you get the beginning number in the first quadrant and multiply it and multiply it by 9. When you get the beginning number in the first quadrant and add it to 8, you will get the last number, which is 9. 1 plus 8, which equals to 9. Then, to get another formula to get the last number, you know this is the first quadrant, which is represented by 1. So when you say first quadrant, which is 1, times 9, it will give you last number, which is 1 times 9, which is 9, which will give you the last number. So let us go into questions and do some examples so that people can understand more about numeric correspondences, because you won't be able to apply these formulas unless you know the questions, how they are involved. So example questions. We are going to look at example questions. Example questions. You know, the first question is, they can ask you list. Question 1, list the 100th quadrant. List the 100th quadrant. So, as I told you previously, while writing quadrants, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the first quadrant. So, it is very tiresome to write up to the 100th quadrant. Very tiresome. You have to write the second quadrant, the third quadrant, the fourth quadrant, the fifth, up to the 100, which can take papers. But we can write in a quadrant using our formulas without listing. So, how do you get the 100th quadrant without listing them all but using formulas? First of all, given that we are looking at the 100th quadrant. So given that quadrant number equals to 100. Then when we know the quadrant number, we can find our last number in that quadrant. How? By saying last number equals to quadrant number times 9. Why do we multiply by 9? Because there are 9 digits in any quadrant. So, since we know our quadrant number, which is 100, then times 9, which is 900. So the good thing, we have found our last number in the 100th quadrant, but we have to find other numbers so that we can list the full quadrant. So we find our beginning number. These formulas, we have listed them before, so when you don't know them, you recall back to the video and you get the formulas. Beginning number equals to last number minus 8. Already we've got our last number, which is 900. So 900 minus 8 equals to 892. Not so? 892. So therefore, since we have got the beginning number in the 100th quadrant, so this is our last number. So the quadrant we are going to write has to have 892 as the beginning number and 900 as the last number. So we begin, therefore, the 100th quadrant is, we begin 892, 893, 894, 895, 896, 897, 898, 8998. This is 900. So, have you seen how we've got the 100th quadrant just using the formula without listing all the quadrants up to 900? You know, before proving this formula, I had to list all to find out it's true. You can list it and you find out this true, but we got the 100th quadrant without listing all of them. Example question 2. List the 1000 quadrant. So as I told you earlier, you cannot write up to all this quadrant up to the 1000 quadrant. So here we apply the formula. So solution, given that quadrant number equals to 1000. So last number in the 1000 quadrant equals to 1000 times 9, which is 9000. Beginning number in the 1000 quadrant equals to last number minus 8. We have our last number 9000 minus 8, which equals to 8992. Sawa? Therefore, the 1000 quadrant Therefore, the 1000th quadrant, 1000th quadrant is, we have our beginning number, we have our last number without writing it. 892, 893, 894, 895, 896, 897, 898, 899, 9000. We are able to list the 1000th quadrant without writing them all, but using our formula. This is a very awesome proof to our nation and to our country. So we're going to look at the last example. Yeah, and I will be providing a future tutorial with more examples. So, example question. Example question 3, which is going to be our last question. In which quadrant is 34? In which quadrant is 34? And another sub question in the same question, show the numeric correspondence. So the numeric correspondence, numeric correspondences of 34 in the 11th quadrant. What do I mean here? We want to find which number corresponds to 34 in the 11th quadrant. So let us start off the first one. In which quadrant is 34? How do you find, just given a number, how do you know in which quadrant it lies? Solution. You first find the numeric sum. Numeric sum of 34, which equals to 3 plus 4, which equals to 7. Then, using the numerical locator, as we know that our first quadrant is the numeric locator, using the numeric locator, which is the same as the first quadrant, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have seen 34 adds to 7, and the position of 7 here is this. So, therefore, 34. Therefore, here, so 34 is found in the following quadrant. You write, you see the position of 7, then you write there 34. You continue 35, 36. Then it's very easy to fill in the whole quadrant because you've seen the position of 34. 34 corresponds to 7, so it lies here. So you can fill in the rest of the quadrant. 34, 35, 36. So together, here we put 33, 32, 31, 30, 29, not so, 28. So this is the quadrant of 34. So how do we know that which quadrant is 34 in? What is, you find the quadrant number. Quadrant number of 34 equals to last number divided by 9. So what is our last number here in the quadrant, which 34 is, but we don't know which quadrant it is. It is 36. Divided by 9, which equals to 4. Therefore, 34 is found. Therefore, 34 is found in the fourth quadrant. You can list them from the first quadrant up to the fourth quadrant because it's very easy and you see the truth about this. So we have found 34. So we are going to tackle our second question, which is show the numeric correspondence of 34 in the 11th quadrant. Which number corresponds to 34 in the 11th quadrant? So which number corresponds to 34 in the 11th? So given that quadrant number, which the 11th quadrant, so we know the quadrant number of the what? The 11th quadrant. But we want to find the number which is in this quadrant, which corresponds to 34. So we begin quadrant number equals to 11. So last number in the 11th quadrant equals to 11 times 9. Then beginning number here equals to 99, sorry. Beginning number in the 11th quadrant equals to 99 minus 8, which equals to 91. So, since we have the beginning number and the last number in the 11th quadrant, we can list our 11th quadrant, which is 91, 92, 93, 94, 95, 96, 97, 98, 99. Have you seen? Our last number is 99 and our beginning number is 99. Now we have found the 11th quadrant. So we want to find the number which corresponds to 34 in the 11th quadrant. So since we know that our numeric sum, the numeric sum of 34 is 7. By adding 3 plus 4, then using our numeric locator, you know the digits which are in our numeric locator, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So, since 34 corresponds to 7, so even the number which corresponds to 34 must lie in the same position with 7. So we find out which number lies in the same position with 7 in the 11th quadrant. It is 97. Let us find out its numeric sum to find out that it corresponds to 34. So the numeric sum of 97 is 9 plus 7, which equals to 16. 1 plus 6, which equals to 7. That is why 34 corresponds to 97. Therefore, 34 corresponds to 97 in the 11th quadrant. So, there are many questions that can be asked in numeric correspondences. We can work on them. Thank you for being with me in my tutorial. When somebody from Uganda develops such a proof and it is published in our country, it improves our academic picture and it can attract students from various countries to acquire our